Hi, I'm Eugenio. I'm a PhD student at this university. And some days ago, my supervisor Sergio Jesus asked me to present this project SoundFishing to his master class. And I recorded my presentation using my digital portable recorder, and you are going to listen right after. Hey, ciao! So to introduce myself, I'm Eugenio. I'm a French engineer, and here I'm a PhD student, a researcher at the University of Algarve in the laboratory called SIP Laboratory, with Sergio Jesus as boss of this laboratory. And last November, I started a personal and scientific project called SoundFishing, so aiming at briefly recording what we call underwater soundscape. So the output of this project, SoundFishing, I do YouTube video on a channel called SoundFishing. And this project has two goals. First is to do science dissemination on underwater soundscapes. So what is an underwater soundscape? It is the resulted sound at a location in a marine or an aquatic environment of all the sound sources that are present in a marine environment. So what are the sound sources that are present in a marine environment? So they are here. Geophonic sound source, so climatic events like rain, waves, geologic events like earthquake or volcano. There is also biophony source that comes from the marine life. So we know, perhaps you know that dolphins are doing whistles, whales are doing echolocation, but the fish are also making sound, as well as invertebrates. So this is biology sound, and perhaps you don't know it, but it's very interesting to dive into those type of sounds.
Well, you know the sound made by whales, so they vocalize very loud, so you can hear them. Dolphins and invertebrates and fish probably not, but whales probably
Yeah.
yes.
And there is also anthropogenic sounds. Anthropogenic sounds, it's sounds that come from human activities, so our industry. And we consider them as noise because they are more a menace for those ecosystem, for dolphins, for fish, etc. And here you can see a boat, a merchant ship, wind farms that are doing sound. This is the other photo, it's a pile driving. It's when we want to put a pile to build a wind farm, for example. The other photo, it's a sonar, so it's a tool we use to understand the aquatic environment through sound. And the last photo is what we call the seismic survey. A seismic survey is to detect where there is oil gizments beneath the seafloor. And this makes a lot of sound and a lot of noise. So I want, with this project SoundFishing, to do scientific dissemination in this topic. And as well, I want myself to discover underwater soundscapes. Because underwater soundscapes, we don't know nothing as a human, because our ears are in the air, not inside the water, and our ears are not made to listen the sound underwater. And it's very nice to put a hydrophone and to listen, to understand what is the characteristics of all those soundscapes. And these are six video I did on my channel. So one I recorded here at Praia de Faro, one in a river in France, another one in Venice, another one in a fresh water lake in France, another one in the Atlantic Ocean, not on the coast, and then another one in the hill of Algarve near Salir. You know Salir? No?
What?
Salir, the city Salir. It's north to Lolé. Salir, ouais, Salir. Salir. So this is my equipment to record an underwater soundscape. So first, I need a hydrophone. So this is my hydrophone. It's what we call a piezoelectric transducer. So it converts the acoustic pressure into an electrical signal, but not an electrical signal, a difference of potential in volt. So I have 15 meters cable. It's a bit short for doing very good underwater acoustics, but for me, to handle it, it's very good. Then I record this underwater acoustic pressure with what we call a portable digital recorder. So I plug the hydrophone to this recorder to record, to save a file, a WAV file, etc. For that, I need what we call it's an adapter, because this is it's a micro jack, and I need it's a XLR to record with this recorder. I need an XLR converter and also an amplifier. So I record this with a sample frequency of 44 kilohertz. So what is the maximum frequency I can record? If I record with 44 kilohertz? No? Because me I see a Theorema de Nyquist.
You already, there is a response.
Yes, 22. I can hear up to 22 kilohertz. And my hydrophone can record sounds up to 10 kilohertz. Okay? So, and then after I can listen the sound in real time with my headphone, and so this is very good. This is very fun. As well, here you have what we call the hydrophone sensitivity. So it's how much my hydrophone can listen a sound, an acoustic pressure with a frequency. This is like a filter. This is a filter of my hydrophone, if you want to have the signal processing explanation. So this is my diagram of my, yes, I think I said everything for this.
You need this sensitivity if you want to have calibrated measurements.
Yes.
Where you can say that you represent a level, and this level corresponds to what the pressure that was measured. It's not just a oscillation, it's calibrated values.
Yeah.
That's the principle.
Yes,
now,
yes.
Whether you can do that or not.
This I have to highlight this. So here I have the sound here. So the real sound, the real pressure that is captured by my hydrophone. And then it goes to my SD card, and there is some box. The problem is all those boxes, they change the signal. My hydrophone, you see it change. If you see you saw what is a filter, it change. It modify my signal. So to go back to the truth, the real value, I need to know how my signal is changed. So here I have my hydrophone sensitivity, how much I apply my signal is the amplification of my signal. Also my recorder amplifies the signal, and then after, here there is nothing. So this I need to know.
Yes, basically when you have your digital signal, you have to sort of go back and use all the information until the hydrophone in order to, but sometimes it's not easy. It looks easy, but it's not.
No, it's, and I didn't calibrate my amplifier and my recorder, but it's going to be done soon. And then this is my deployment strategy to record the soundscape. So I can deploy with a mooring line. This is nice, I like, or with a fishing rod here, or by hand. Okay. So they all have pros and cons to this strategy. Do you have ideas? Like, for example, why it's good the mooring line, to use the mooring line, whereas the rod? You have ideas or not? Why it's good? Yes. And also, there is other, but more stability is what I like, yes.
You can decide the height better?
Yes. I can also put a sensor if I want, for example, to measure the salinity or the temperature of the water close to the hydrophone. Also, there is a disadvantage, is that in a strong current, all my material, so my anchor, my line, can make noise, self noise, because that's self noise, and this is not good. With the fishing rod, you see the advantage of this method?
Seems like the most stable, the least noise.
Yeah, it's the same. If there is current, it makes noise. The thing is more portable. I don't need the problem of the line. It's a 15-meter line plus the buoy. It's a lot to carry, etc. With the fishing line, and by hand, it's a bit it's bad because we cannot record more than 5 minutes because it's tiring, or 10 minutes. But if we have nothing, it's good to have the last option. So, for this project, I responded to some questions already. I explained my science on YouTube channel that is a free users. So a lot of people that are not studying in a university or are not linked with this subject can be aware, can be interested. So I responded for now to do several questions. The one that I prefer is flow noise and rain sound. So I recorded during a heavy rainfall, and this is very interesting. And I really enjoy these recordings. And also I discovered sounds. So those sounds. This is the sound of a fish. So
you have to explain what you see in the axis of this.
Yes. So this is a spectrogram. You know what is a spectrogram? So
no, they will learn that.
This is the time. This is the time, and here is the frequency. The frequency domain. Okay. So you do. It's a lot of Fourier transform. So I have the indication of the frequency that are present in my signal over the time. So this is a spectrogram. And so by looking at the spectrogram and also hearing, you can recognize some fish. So this is what we call a toad fish. I recorded in the Ria Formosa. This is a drumming call from a fish. So fish, they have swim bladders. You know what is a swim bladder? Wow,
it's a kind of a sac.
It makes them up and down.
Yes.
And they
it allows to get to that certain depth or to go to the surface of the.
And they have muscles close to their swim bladders. And by doing percussion with that, they can do calls. And they use that for signaling their presence or breathing.
It's like a drum, like boom, boom, boom,
yeah,
boom.
sounds like that, but low frequency. And this is dolphins calls, whistles that I recorded at the Praia da Arifana. You see where is it? Praia da Arifana? It's nearby Algesur. So this is a biologic sound that I recorded. Anthropogenic sounds. This is a jet ski in in Ria Formosa. This is a boat in Venice. And this is an echo sounder, so it's a sonar to measure the depth used by a boat. And after, geophonic sounds. So this is the sound of the rain. And this is the sound of a waterfall in a river. Yes. Sorry, you don't listen them. If you want to listen them, follow my channel, and so my perspectives. I need to calibrate my equipment, and also I want to do more scientific work. So to pass from the illustration of Soundscape to the explanation, I'm already on project like that. So doing signal analysis, more deep in science, and also deeper in science, and also present articles, scientific articles on my field. So as Sergio told you, we are going to see one of my videos where I explain where you are going to see how I deploy an equipment in Venice. So the video was recorded here. Some of you went to Venice already? No? So it's, but you know a bit how it is. It's made of canoe. And I recorded here in the main canoe. And it's called Calle de la Donzela. Perhaps you understand because you are Portuguese. What does it mean? And so yeah, so this is it's a lagoon like Praia Ria Formosa, but the thing is, since it's in a Mediterranean Sea, there is no tide. There is tide, but so the water is almost constant. So it's a bit, and I think it's a larger lagoon. I enjoy the video. Yeah, in Venice. So we are going to record the underwater soundscape. So what can be the underwater soundscape in Venice? Mostly boats and perhaps fish. I'm very happy to record in Venice because I was not supposed that second video in Venice. I have my hydrophone here, my A5. It's a broadband hydrophone from 20 Hz to 10 kHz. Very good to record a lot of type of sound like boats, fish, and also cetaceans. And we can listen in real time with a headphone the sound. So let's go. Let's go. So right now I'm listening the propeller. It's doing the we are hearing the gondola. I'm hearing an alarm. Now I have the gondola. Oula. Oh, it's this boat. It's making very loud noise.
That's it?
But I think that's it, huh?
I'm sorry I talk in the middle of
Well, it's
the
okay.
recording. You
Well,
can
I hope you liked.
tell-
If you have questions, you can ask now. I put the QR code of my YouTube channel. I have the key of the room. If I don't have 1, 2, 3, 4, 5 new follower, I don't open the door. No, I'm joking. You do whatever. If you like, you follow. If you don't like, you don't follow. No problem. And what's more? But yes,